Okay, so we're asked to find the coefficient of x to the power of 20 in 1 minus 2x to the power of 4 to the power of 7 using the binomial theorem. So I've just put the equation for the expansion of the binomial, the general formula of it, on the left of the screen. So it says that for the form a plus b to the power of n, the binomial expansion will be from k equals 0 to k equals n, so all those terms, n choose k times a to the power of k times b to the power of n minus k. So let's just establish what our a, b, and n are. So for the expansion, our a is equal to so it's the first part, which is 1. b is equal to negative 2x to the power of 4. And n is equal to the power, which is 7. So we would just input this, and for k equals 0 to k equals n, we would find all the terms. However, there is a much more efficient way of doing it, which is instead of expanding the entire binomial, just find the term that contains x to the power of 20 and find the coefficient of that. So we can do that by determining which value of k will give the x to the power of 20 term. So the first thing we want to do is find our k. So we're not going to go from k equals 0 to k equals n, we're just going to go straight to that term. So what we have to notice is that our b is the only place where we have an x term in there. We have x to the power of 4 in our b. And we want to find x to the power of 20, which is not going to happen with a equals 1 because that does not contain x in it. So we need to figure out when we raise b to a power, so in this case it's b to the power of n minus k, what will make it x to the power of 20? So I'm just going to write down b to the power of n minus k is equal to x to the power of 20. So if I just substitute b in there, we get negative 2x to the power of 4 to the power of n minus k is equal to x to the power of 20. Now, I'm just going to ignore the coefficient for now because we want to figure out what the power of the coefficient, the power which x is raised to is. And we need to figure out which one gets it to 20. Then we can figure out the coefficient stuff later. So we get, using indices, x to the power of 4n minus 4k is equal to x to the power of 20. So that means that 4n minus 4k is equal to 20 since we have the same base. We know that n is 7, so 4n is 28. So 28 minus 4k is equal to 20. So just doing a bit of rearranging, 4k is equal to 8. So k is equal to 2. So we know that when k is 2, that's the term that's going to contain x to the power of 20. And all we do is to substitute all our n, a, b, and k values into that part. So we get 7 choose 2 times 1 to the power of 2, since a is 1, times b to the power of n minus k, which is negative 2x to the power of 4 to the power of 7 minus 2. So that becomes 7 choose 2, if we evaluate, becomes 7 choose 2, that's 21. So 21 times, and then 1 squared is just 1, times, and so we know 7 minus 2 is 5, so that means negative 2 to the power of 5 will give us negative 32. X to the power of 4 to the power of 5 is x to the power of 20. And if we do all that together, do 21 times negative 32, and times 1, which gives us negative 672 times x to the power of 20. Since they want the coefficient, though, which is just the part next to x to the power of 20, we can say that, therefore, the coefficient of x to the power of 20 in 1 minus 2x to the power of 4 all to the power of 7 is negative 672. And we did not have to do the entire binomial, which would have taken, the entire binomial expansion, which would have taken a lot more time. So that's our answer.